So here we're just going to get back to the indefinite integral here. Let's evaluate the integral. Right. So let's go ahead. Write it down, and we're going to go further into it. Okay. So for this problem right here, would you like to think of a substitution? It looks a little bit pretty all over, right? So for this one right here, allow me to again suggest a substitution for here. Why don't you substitute with a cosine inverse of x here? Okay? Cosine inverse of x. And so, but now doing this substitution right here, then you gotta bring back your count one understanding that what's the derivative for cosine inverse? That's the count one material right there. That we need to look back a little bit. So it's 1 over 1 minus 1 over square root of 1 minus x squared. Okay. Yes. So that's the one. And so we're gonna rearrange this into du equals 1 over square root of 1 minus x squared times dx. See what I'm doing now? So the substitution I've been using, the style, and I'm talking about the style that I've been going with, the style that I've been approaching is always I solve the dx, right? But now in the end, at this point in your understanding, we can be even more flexible than that. And as a matter of fact, the boss was using this style yesterday right here. So you see, you don't always have to solve for the dx here, right? But right here you can see the du equals the expression 1 over the square root of the 1 minus x squared times the dx, right? You can start substituting right here already, because right here in your problem, think of that as following. This integral really is the same as you can rewrite, just rearranging it. It's a cosine inverse of x, right? All squared times the 1 over square root of 1 minus x squared dx. So you see what I'm doing there? So now when you put it in all of the substitution elements, then that, making it u squared. But all that here is substituted by du. Because it's a 1 over all that square root and then the dx, right? So it's a substitution in the end. So here we don't have to specifically solve for the dx. Because if you solve for the dx, we're still gonna be able to substitute, and then we're gonna spend more time canceling it out. See what I'm saying? No? So here it's just simply a little bit even more convenience. But I wanted to wait until you guys have seen enough actions, right? So that we can keep introducing, more the flexible style. So here it's just like the flexibility of how we're reaching to the problem. Okay. But so now we have successfully substituted. So these are all the substituting elements here. And so now, have I washed away completely the old variables? Yes, I have. Right. And have I made the problem simpler or easier to handle? Okay. Yes, it clearly is. Right. So now it's going to come out being 1/3 u cubed plus c. Okay. And then that's back to the original variable. It's going to be cosine inverse of x to the third power, right? With a 1/3 in front, and we add c. We're done with that problem. One more problem down. Okay. And we keep putting in more experience into our work with that. It's just that one simple fundamental I introduced 2 lectures ago, right? And now we keep going further and further into that. Okay. It was actually this derivative right here is a negative. Okay. So we can make that fix for you carefully. Yes, I remember incorrectly. Okay. And that's this one right there. And so your function here, you can easily think of that as having a negative right there, with the negative sign here. Because it was originally all positive out, right? So we can think of that as a minus sign of that. So now it's turning it like that. Okay? And then so all that here goes into a du, and then we still got the u squared there. We've got the minus 1/3 after that. Okay. I'm going to keep pushing it further to the next example problem here. So, how about this? Now, we have never found, right from the beginning days, we have never found the antiderivative or the integral for tangent of x, right? So let's now get to it. At this point, we are ready. Because earlier in that, I introduced like this, what is the secant squared of x, right? Taking the antiderivative that goes boom directly into a tangent, but then finding the antiderivative for a tangent, we've never learned that. Right? We've actually never even bothered getting into it until now. So here's the idea. See, the reason I put this in now is that sometimes even before we can do a substitution, we got to do a couple of the algebra treatment for here. Now, what's tangent famously known as? That's the most ground up definition. What's tangent defined as? Sine over cosine, right? So you can never go wrong with that. So with your integral here, you can rewrite it as a sine of x over cosine of x. Very good. Okay. Yeah. So now in this case right here, here's I'm going to suggest substituting cosine. Like that. And you guys, as you guys keep watching me going along with these examples here, as you build your experience, then it's one day it's going to all come and be a good experience for you guys here. But so du dx, right, will be a negative sine of x. Okay. And so in that way, again, I'm going to go with the following. Du equals minus sine of x dx. Good. Okay. And then you also have your choice to divide both sides by that minus sign right here. But then from right here, I can already see, right? It's quite trivial right here. This sine of x over cosine of x times dx right here, you can rewrite it purposely as a minus integral, right? A negative integral with minus sine. Right? Think of that like this. Minus sine of x dx times with a 1 over cosine of x. I'm just rearranging my integrals again. Okay. Keep in mind now that in these days we already understood that the d expression here means a differential, and it's multiplied, right, with your function again. Okay. And so now, do we recognize the substituted elements? So we got 1 over cosine is being substituted by u, so I have a 1 over u, right? Good. And then there's that minus sine of x dx. That product there can now be safely substituted by du. Right? Now we have a negative integral, right? 1 over u times du. Right? And once again, we asked ourselves the two questions, right? The first one is, have we completely washed away the old variables? And we have. Right? And then so the next question comes here that did we make the problem easier or any simpler? Yes, it is. Right? Now we can use just a simple what? The 1 over x and 1 over u right here. So it's making it minus natural log of absolute value of u. Right? Let's see. Right. But then we definitely don't want to stay with that, but the variable u being a final variable, right? So we bring it back. We bring back what our substitution right there. So it's minus natural log of cosine of x. Right? Let's see. So that's your final answer right here. But now when it comes to those trig functions, especially trig and blended with the logarithms and all that, I want you guys to raise your awareness a little bit in case you read some of the different textbooks out there, okay? Surprisingly, that when you read textbook, and in these days, when you hop onto Google, you're going to see the formula as follows. The integral for tangent of x is indeed natural log, no minus sign, natural log of secant of x plus c. That's actually the formula that's tend to be used out there, and tend to be a little bit more commonly out there. So did we get the wrong answer? We did not. Okay. Remember that negative sign here? The negative sign here really means, we can now bring the negative, because it's a -1, right? So with that coefficient and with the property of logarithm, we can do this as a natural log of, and then we got the cosine of x. Okay. Actually, violating the order a little bit. It's absolute value, right, of cosine of x, but then to the -1 power. To take the reciprocal of that. See what I'm saying? Okay. And what's the reciprocal of cosine of x? It's the reciprocal. It's not the inverse. That's why I didn't write the -1 right here. The reciprocal is going to look like this. That log of 1 over cosine, right? But what's 1 over cosine? 1 over cosine is secant. Right? And that's why you're going to see this forming a lot more commonly. Right? Maybe the authors out there try to write it in a way that it skips out the minus sign in front. Right? It looks awkward to have a minus sign in front, but then leaving that as a 1 over cosine, and it looks even worse because we've got a fraction in our formula, right? So we write it as a secant, and we reuse all of that, bad-looking nature again. Okay. But that's how we're handling the problem. Now we have to found our the antiderivative for tangent of x. I also put that in the box indicating it deserves your attention to remember it at some point. Right? All right. Let's look at another one. But you see, what we have learned from this example is that when we start having a function that comes from a mix between sine and cosine coming together, right? We can pick one, and normally you see in a setting like this, and I pick the one from the bottom, one function, because the cosine, when you take the derivative, it's going to be the sine, right? Well, when you pick the sine from here, the substitution and the derivative of sine is going to be the cosine. That's kind of like becoming a strategy for us for some of the later problems. And this is what I mean right here. Let's look at something like this. Part C of the example. And so this example 3 that I'm bringing up now, I'm purposely bringing in the more challenging kind of problem. Okay. Think about we have a sine. Pick a number for me. Pick a number. 4. Okay. We're talking about sine to the 4th of x, right? Times the cosine of x dx. Okay. Something like that, right? And generally speaking, it's the kind of function where it's one trig function is raised to a high power, and then multiplied with another trig function in single term. This is single term right here. That's what I'm saying. It's like power 1. But then the other guy can go 4, it can go 5 on one way, right? But the trick for getting through with this problem, I'm going to make a u substitution to be the sine of x. You guys with me on that, okay? And so now doing this, I'll have du dx, right? That will equal the cosine of x. And so we're going to do the usual thing, thinking of this as a fraction of two differentials. I'm going to have du equals the cosine of x times dx. Good? And then so in that new style I'm introducing, right? You can still stick with the old style, but you see I keep bringing in new style to make you guys be aware of more flexibilities out there, right? When you handle a problem. So this entire cosine of x can now be substituted and substitute for that, right? And then the u equals sine of x, substituting for the sine of that. So after putting in all the substituting elements, we're looking at u to the 4th, right? Times du. Okay? Now all two checkpoint questions are all satisfied, right? I mean, did we completely wash away the x variable? Yes, we did. Right? And did we make the problem simpler? Oh yeah, sure we did. Right? So now go ahead and advance. Right? We have a 1/5 u to the 5th, right? Plus c. Right? And that's making it 1/5, and at the end, of course, we definitely want to bring back our old variable, right? Our original variable back in. So now it's turning out to be cosine to the 5th of x plus c. That's how it's done. What's that?
Was it u sine of c?
Yes, thank you. Thank you. Thank you. Got you that. Sine up. Sine to the 5th of x, right? Please catch up with me, guys. Go ahead, spend some time writing it down. So the first one, anyone would like to pick a substitution for me? At this point, you guys have watched me doing a lot of each problem already. Do you see a routine and how I keep picking my own new request for suggestion? And it's just something that has been working for me, but I'm not saying that it's 100% guarantee that it will always work, okay? But at least anyone recognize how I have been doing it, how I've been choosing the new so far? And that will never limit you down to your own way of checking it. I mean, picking a new.
It looks like you're typically choosing something that's like within another function.
That's exactly the idea again. We pick something that's inside another function. See what I'm saying? Now, typically, okay? Typically, I like that. Yes. So that's why thinking as a choice, right? The sine of x and the cosine of x would be the better one to choose. I'm just saying the better one, right? There's no right or wrong again about picking a substitution. Let's see. Let's try out with that one first, right? Let's set a higher priority for that one first, because the cosine here is indeed inside of the e to the x function, right? Yes, I agree with that. And so that way right here, go ahead and go with that. But still, leave it some chance for being off sometimes, right? Still leave it some chance that hey, who knows, things doesn't work out. But for now, u equals cosine of x. We have du dx, right, equals, what is it going to be, guys? Minus sine of x, right? And then, yes, you can rearrange this as du equals minus sine of x dx. For this one here, I'm going to get back to my traditional mode. I'm going to solve the dx specifically with the important focus. So we've got a du multiplied by minus sine of x here. I don't want to do the rearranging too much. So the function here goes, I mean the integral goes sine of x, if we get a substitution, it stays the same, right? We got e to the u, and then the dx here is now substituted by du over negative sine of x. Okay, now we can cancel out the sine of x away, and the negative sign got left over, right? So the integral in the next step becomes minus integral e to the u. So, can you see ahead? It will work this time? Okay. Let's get that into a minus e to the u plus e. Now you can put that into your note somewhere that, and like I said, it's not a guaranteeing rule, it has been working for years for me, right? And it's good that everybody see that as well. So we tend to right, pick the one that's inside another one. We tend to pick that one to be the one that's substituted. Okay, sounds good with that. And so now, but like I said, don't just leave it like that, right? So we got the next step right here is to go ahead and bring back the original variable here. So you got minus e to the cosine of x, right? Plus c here. Guys, I forgot to keep asking you guys to check this, but check the answers. Check the answers. Make sure we did all the work correctly. And that's the only way of doing that. Check the answer, even though I will never require you to include the checking work on your written work. But make sure you guys check to make sure that we arrive at the correct answer. All right. So, in that way, let's. So now promise me that anytime you face any struggle with these things, keep letting me know, because I'm at the end of my creativity. You see, like there's no instructor that can cover all kinds of problems. There's a whole world of problems you can do substitution for. So you're gonna have to also, you can only explore on your own again as you're facing some of the homework assignments. And then this is where any textbook is useful right there. You can always grab it in textbooks, right? Not only the one suggested by the syllabus here, but you can pick any textbook and grab the problem and really try it on your own again. Okay? And so I'm going to bring you into the fourth example where problems may even become a little more creative. How's that? We need some creative way to approach a problem here. So let's think of this one right here. before you do things creatively, but we always rely on that those general guidelines that we have seen earlier. 5x. X to the fourth plus 1. X. Okay. Okay, so I want you guys to leave before you guys try it a little bit. That's why, like I said, as far as when it comes to picking a substitution, there's no correct substitution. Okay, what matters is we can make it work. We want to say that. So, would you like to pick a substitution? Okay. Some problem it may spend forever to get through with that. Okay. It's completely okay.
X to the fourth plus 1.
X to the fourth plus 1. Okay. Nothing against that one. No judgment. Okay. X to the fourth plus 1. Like I said, you got to completely let go of the worry about the right or wrong. Okay? There's no judgment about it. There's no correct one. It's just will we be able to make it work? That's what matters. So this is the chosen substitution. We go, how about du, right, equals, du dx, right, equals 4x cubed. You guys agree? Right. And then that means dx, here solving for dx, we're looking at du over 4x cubed equals dx. Are we good at that? So now we're ready putting it in. Right. We have the function here, see that 5x did not get a substitution. We leave it there for now. The entire x to the fourth plus 1 was chosen. Okay, so in the denominator we have an over u right there. The dx now can be replaced, right, by the du over 4x cubed. Okay, and so yes, some cancellation will definitely happen. We have a 5/4 being isolated out as a coefficient, so I can put it in front, and then I have a du. The x cancel with x cubed, but leaving an x squared here in the denominator. So we got 4x squared u. So the first question that arose here is that did we completely get rid of the x variable? Did we completely get rid of the x variable? We did not, right?
Why is it 4x squared instead of just x?
So it was 4x cubed earlier, right? And then we cancel that x away. See what I'm saying now?
Yeah.
So now we have, but you're right, I pulled that away already. I shouldn't have the 4 here anymore because it's here. Okay? Thank you for catching that. Mistake of mine, okay? Okay? But then in the end, did we get rid of the x completely? We have not, right? You want to say that? Let me actually add in for you guys some more experience in your learning. Okay, so this is all about experience. So even sometimes it feels like we're at that end and we still cannot get the x away, right? It's all about the substitution again, right? There's no right or wrong. See what I'm saying? No, still with this, what else can we do? If u equals x to the fourth plus 1, can we subtract 1 from both sides, making it u minus 1 equals x to the fourth? Yeah? You guys agree? And then, so can we take a square root, actually? So that now means x squared equals the square root of u minus 1. You guys follow it? Agree? And so, if we put that in here, then it seems like we handled a problem that we completely washed away the x variable, right? Because the x squared now can be changed into a square root of u minus 1. So you got u times the square root of u minus 1. But in the end, did that make the problem any easier? So we can even manage further to get the x completely washed away, right? But then we ask ourselves the next question right here: did we make the problem any easier? Probably is still a challenging one right now. You want to say nowhere to go from here. And so, like I said, nothing wrong about that, right? There's no right or wrong. It's just this one here, it didn't work for us. It didn't work for us. See what I'm saying? See, when I first started out, like you guys are here, it's the same kind of thing that happened. Right? You got to spend hours a day for one problem sometimes. Right? You get it, you find it a good one to work. So now let me suggest based on my experience. Okay? to see, but along the way that we want to see something inside another function, it's a little hard to recognize. The x to the fourth right here, do you see the x to the fourth is an x squared inside of a square function? Yeah? Okay, so why don't you pick the x squared then? You pick the x squared. So out of the whole denominator, I only substitute u for x squared. See what I'm saying? So doing that, then this is what I have. U dx, right? Equals 2x. You guys follow it? Right. That will make it du over 2x, right? Equals dx. So now you guys have seen enough of these actions. Eventually, that will cancel with the 5x here, right? When we substitute it in, so that will bingo, clear away the x already. So now, but let's put it out of the substituting element. You got a 5x here, right, over, so it's not like the whole thing becomes a u, it's only a u squared plus 1. You guys follow it? Right, here we got a du over 2x. Right? Now, gladly, we easily cancel away the x's, right? And then we can put the 5/2 in front as a coefficient. We got the du over u squared plus 1. Agree? Okay. We completely washed away the old x variable. Did we make the problem easier or more recognizable? More easily recognizable? You think of this as a 5/2, 1 over 1 plus u squared. Then you always have your right to rearrange the sum, right? And talk to you. Do you recognize this thing there? More count 1 to bring back here. So math is always a link, right? When I go to learn like that, don't forget about it. Keep bringing it back to the new stuff you've been learning.
Inverse tangent.
The inverse tangent, yes, there you go. Right? This thing goes straight into the inverse tangent, right? So that now tells me that we got the 5/2, right? Inverse tangent of here's variable u, right? Plus c. Sounds good? That's why it takes some creativity like that, right? And then I'm just trying to, but see, the problem with creativity is every problem has a different creativity like that. It's not the same rule for every problem. And so the final answer here will come out being 5/2, the tangent inverse, right, of x squared plus c. See that now? All right. After this one, I think that should be it for our learning about the substitution methods. You guys have seen enough of doing examples, and then I'll let you guys start doing things on your own again, right? By going through the assignment, and then when you face some struggle, of course, it should be the way how it is, right? And then when you face a struggle, you're gonna meet with me or find me, and I can help you out. And then also leave some window for me that there's some problems that you bring to me, I'm stuck too, It happens like that. Alright, so let's look at a problem like this. And let's call it now part B of this creative example over here. The example that requires some creativity. How about 3s multiplied with the square root of s minus 2. Okay. And yes, the main variable here is the s variable. So it's got s and the ds. Go ahead, pick a choice again. What seems natural for you? Just pick that. There's no right or wrong. Put away to worry about right or wrong again.
S minus 2.
S minus 2? Okay. No judgment again, right? No judgment. So let's stick with s minus 2 for now. If it doesn't work, we're going to switch to a different plan, right? Be open like that. So if it's s minus 2, then we're looking at du ds, of course, not x, right? Du ds equals 1. Sounds good? And so that gives me simply du will equal the du differential will simply equal ds. Right? So the substitution goes a little too simple, right? It goes a little too simple. And so your problem here becomes, after we're putting in the substituting elements, notice that the s did not get a substitution, so here we got the 3s that's still stuck here, right? And then the square root of a u, and then there's a du right here. We stuck with the s. See what I'm saying there? Okay. But actually, you have seen how I've done this a little bit action earlier. Okay. Don't give up yet. Sometimes it seems like hopeless and we couldn't get the old variable away. Don't give up yet. Tackle down right here. If u equals s minus 2, can we also think of that as adding the 2 over, so making it the u plus 2 equals s? You got the idea? It's all about a substitution. See what I'm saying now? Right? Have I found a way to substitute the s away? It's a 3, right? S now is a u plus 2 times the square root of u du. You guys following with me on that again? Now we have completely washed away the old variables, right? Did we make the problem easier? Did we make the problem easier to handle? We actually did. We also did. See, 3, and then now you multiply that square root of u to each term here, making it u times square root of u plus 2 square root of u, right? Du. You guys agree on that, okay? And now that will make it what? This is 3, and then you got the u to the 3/2 power for the first term, right? We've learned that from the earlier experience. This is just 2u to the 1/2 power, right? With that, we got the u right here. So now we can fly, right? At this point right here, it's easy. We can fly easily right here. So it's going to be 3. And then let me put it in parentheses like this. So 2x, right, times the u to the 5/2. We good? Adding 1 to that 3/2. And then I'm going to have 2 times the 2/3, right, times u to the 3/2 power plus c. Then I'm going to multiply that 3 in as well. Here's making it 6 u to the 5/2 plus. And that's making it 4. The 3 cancel with that 3, so it's 4 times u to the 3/2 plus c. And now we're ready to bring back the original variable, right? That's right. So we're going to bring it back. So 6 s minus 2, right, raised to the 5/2 power plus 4 times s minus 2 raised to the 3/2 power plus c. That's how we're done. See what I'm saying there? Okay. So again, there's no right or wrong about the substitution right here, but we gotta do some creativity on top of that as well. Right? Sometimes you just have to blend in some creativity. Good? Okay. Guys, any questions for me? Any other questions?